Hello, here we're going to continue to look at radical properties as a part of 7.4. What we had looked at previously is square roots of numbers that aren't perfect squares. And what we did was we rewrote them using multiplication where one of the numbers is a perfect square. And that gave us an answer like this, 2 square root of 5. To where 2 square root of 5 and square root of 20 are the same thing mathematically, but 2 square root of 5 is the simplified answer. Now you may have noticed that we have not been using the plus or minus with our simplifications. If I was just to ask you the square root of 49, you'll only say 7. However, if we're solving an equation and there's an equal sign, that's when we need the plus or minus, because both the positive and negative values make that equation true. When we're simplifying only, though, we do not need to use a plus or minus. Now, other things that can happen is that we can have variables underneath the square root. Variables underneath the square root are not a big deal. They're actually easier than dealing with constants. All right, and so here's what we'll do. Let's first go ahead and talk about 27 as 9 times 3. We can then square root the 9 to get a 3. Square root of 3, y to the 6th power. Now, the way we're going to do this next part goes back to what we previously had looked at in Chapter 7, to where square roots are actually just something to the 1/2 power, like this. So essentially what's going to be going on is whenever we have an exponent underneath the square root, we're going to be dividing it into groups of 2. And in this case, if I do 6 divided by 2, I would get the 3rd power. So what I'm going to do for this final answer is that y to the 3rd power is going to join the 3 that was already there on the outside. So essentially what we're going to be doing is dividing our exponents by 2 to get them to escape. For the second one, we could split this up into a 16 times 2. We'd square root the 16 to get a 4. And then for y to the 10th power, when I divide 10 by 2 to get it to come out, we'll have 4y to the 5th power with that square root of 2 still left over. And that's all it is to it. So for this one, the square root of 16 is 4. When I divide 8 by 2, we get the 4th power. And that's all it is. So for this one, when we do the x, we'd get x cubed on the outside. Now this time for the y, I can't divide it evenly. So really what we're going to have to do is split it up into a group where I can divide it and then leave the remainder. So 8 divided by 2 is 4, but I am going to have one y still stuck on the inside. This guy isn't divisible by 2, so he's going to stay underneath that square root. So once you get good at these, you should be able to do them very quickly because we're simply just dividing those exponents by 2. So for this one, square root of 64 is 8. For the x, I'm going to split it up into one group that can come out and one that's going to stay. So within our answer, we're still going to have an x left over. Same thing for the y. We could divide that to get y cubed on the outside with one y left over. And then for the z, we'd get z to the 5th power. So these look like they'll be very complicated, but really all we're doing is taking square roots and dividing exponents by 2. So this is going to bring us to scenarios where we can multiply square roots. And this is actually taking us back to previous Chapter 7 stuff, where we can multiply products of powers if they have the same exponent. An example of that would be if I had 6 to the 3rd power times 5 to the 3rd power, I could rewrite that as 6 times 5 all to the 3rd power, because we saw in Chapter 7 that when we're multiplying, We just are distributing that exponent. That's not what we're going to focus on this page, but I just wanted to bring that rule back. The one that we're going to look at is dealing with radicals, and they have to have the same, what's called index. And so for that, what that means is we need square roots and square roots. Square roots actually have invisible 2's right here, but all it's saying is that if we have two things that are both square roots, so if I have some term A and some term B, and they're both real numbers, and I square root them, square root of A times square root of B is simply going to be us multiplying the inside pieces, as long as they're both square roots. So for us on this, what we'll do for the first step on these is we'll need to multiply those inside components. So when I multiply these, we'll get 720 x to the 4th, y to the 5th. Because remember, when we're multiplying same base and same base, you add the exponents. That's old chapter 7 review there. And then we could continue on and simplify this like we've been doing previously, to where I'm looking for a large perfect square within 720. And after you spent some time with it, you'd recognize that 720 is 144 times 5. We would square root the 144 to get a 12. The 5 would still be stuck on the inside. And then we'd do the dividing the exponents by 2. So we'd end up getting 12x squared, y squared, square root of 5y. Because there's one y left over after I divide that 5 by 2. And if you need to rewatch that, or go back to the last page and rewatch that, give it a try. The first step here, though, is to multiply the inside pieces. So here we'll get a 320 x to the 7th power. If you divide 320 by perfect squares, eventually you'll find that 64 goes into it. 64 times 5. We'll square root the 64 to get an 8. For the x to the 7th power, if I divide it by 2, we'll get 3 groups of 2 with 1x left over. Right, because what happened here on the x was it was x to the 6th and x. When I divide that 6 by 2, I get the 3, and that 1x couldn't make it out, so he's still underneath the square root. Now, when you're multiplying these and there's numbers on the outside, they will multiply separately from the numbers on the inside. So for this one, I get a 20 on the outside from the 4 times 5, and then we'll get a 12x squared, y squared. This 12 will split to 4 and 3. When I square root the 4, it becomes a 2. And remember that numbers on the outside need to multiply. So then we'll divide both of these by 2 to get 1x that makes it out, 1y that makes it out, with the 3 left over. Now go ahead and see if you can't give number 3 a try. So pause the video and then make an attempt on number 3. And when you unpause the video, I'm going to show you the work and the correct answer. So go ahead and pause the video now. So here's the work for number 3. You can see I color-coded it in the first part where we've got the 6 coming from 6 times 3. I multiplied the inside components and then started to simplify. When I square rooted the 4 to get the 2 and the 6 multiplied. You can see where I split the x's and y's into groups of 2 with odd numbers remaining. And then we divided those to get them to come out as well. So one more time, give number 4 a try on your own. So go ahead and pause the video and then unpause it and see how your answer compares to the work that I laid. So go ahead and pause the video now. So for this one here, the square root of 30 does not have any perfect squares within it, so we're forced to just leave it as is. So what that means is I'm going to go ahead and add this 30 back down in front here, because this 30 couldn't go anywhere. There's no more perfect squares within it, and then that allows us to see the other variables to where we can divide up the x and y's into groups of 2, leaving any odds left over inside the previous square root.